This is the marking video for the exam on IV characteristics. Question 1a. A resistor is a component that is used in an electrical circuit. Describe how a student would use the circuit to take readings necessary to determine the resistance of R. So R is the resistor, it's a fixed resistor, and we know just from our knowledge that it's an ohmic conductor. And this is a classic test circuit that you should be used to seeing, where you have a variable resistor, an ammeter and a voltmeter with a power supply to investigate the IV characteristic of the component. So the first thing that needs to be done is the switch needs to be closed, or you turn the switch on so you can take readings. You then read the ammeter and the voltmeter. Third, you adjust the variable resistor to change the current or the potential difference. You then take further readings, draw a graph of potential difference against current, and then calculate the gradient R equals V over I. Now just note here that in this case we are drawing V against I rather than IV, because then the gradient would be the resistance, which is what we intend to find out. The reason we take further readings is if we get multiple readings, because we know it's an ohmic conductor, it's going to be a straight line, then if there is a little bit of error, that's fine, because our line of best fit is what we take is how we calculate our resistance by working out the gradient, and this will make our answer for R more accurate. Okay, next question. Describe or explain why the student should open the switch after each reading. And that's because the resistor would get hot if current was left on. So it's important you close the switch, because Ohm's law applies when components have the same temperature. Otherwise that could affect the resistance. 1a part 3. In an experiment using this circuit, an ammeter reading was 0.75 amps, and I've labelled that I. The calculated value of the resistance of resistor R was 16 ohms. Label that R. What is the voltmeter V reading? This is classic calculation question that you need to list the values for with the units. We don't know what V is. The formula V equals I times R. Substitute your values and then you get your final answer. Question 2. A student built a circuit using filament lamps. Sketch a current potential. So current is I, potential difference is V. You might be used to your teacher saying an IV graph for a filament lamp, and you should have drawn something like this. It must go through the origin, so can we label what the marks are for with our blue pens? So it must go through the origin, and it also must curve only in this quadrant and in this quadrant. There should be nothing in these two quadrants here. That's the second mark. Okay, next question. Figure 2 shows the circuit with two identical filament lamps. Whenever you see the word identical for a component, you should make an annotation and note to yourself that it means the resistance is exactly the same in both lamps. So identical means the resistance is the same. So here's the parallel circuit that we can see. So label what kind of circuit it is, because that will help you determine what the rules should be. Compare currents I1, I2 and I3. So you're comparing these three currents, and there's 2 marks available, so there's 2 comparisons you can make. The first is that the current I1 should be the current I2 and I3 added together. So the sum of I2 and I3 is I1. The second thing, since the 2 lamps are identical, it means that I2 equals I3. The other thing that would be allowed in this case is to say that I2, the value for I2 would be twice as much, the value for I1 is twice as much as I2, or twice as much as I3. Okay. Next we have a calculation question again. However, this is a 6-mark calculation, and that should give you a clue that there are two formulae that will be linked together. The best thing to do is, as you're going through, label with the correct letters the values that you have to find out and are given. So, as you can see, I've labelled Q for charge, T for time, P for power, R for resistance. And I need to make sure you write any equations you use and to give the unit. There's a mark available for that. So first, let's write down all of these 4 values, and the things you should have written are as follows. So, first of all, Q equals question mark coulombs, T is 1 minute, which is 60 seconds, power is 3 watts, resistance is 12 ohms. But what can we work out from here? Well, we need to figure out what charge is. But the only way I know, the formula that I know that links at least some of these together is I equals Q over T. But I don't know what I is. So how can I work out what I, or current, is? Well, I know these two are in a formula with I, and that formula is P equals I squared R. So let's go through that step by step. So, first of all, we know P equals I squared times R. You do your substitution, 3 equals I squared times 12. Divide both sides by 12, and square root both sides to get 0.5 amps. Now that I know current, I can use my formula I equals Q over T, substitute 0.5 equals Q over 60, multiply both sides by 60 to get 30 coulombs. However, my answer is not finished yet, because the question is asking me for the charge that flows through the cell in 1 minute. I have only calculated the charge flowing through each lamp, and there are 2 lamps in total, lamp 1 and lamp 2. So I need to double the charge from 30 to 60 coulombs. (2D) is about this circuit, and I've labelled my component LDR, light dependent resistor, because remember it looks a bit like a resistor and it depends on the light coming in. So you need to explain how the readings on both meters change. So you need to mention both the ammeter and the voltmeter in your answer when environmental conditions change. Of course, that's going to be light. So here's the first mark. When light intensity increases, the resistance of the LDR decreases. That's a relationship you should know well. Next mark is for saying what effect the resistance changing has on the potential difference, and therefore the reading of the voltmeter. So this causes the potential difference across the LDR to decrease, and so the reading on the voltmeter decreases. The reason for that is because resistance and potential difference are directly proportional. So if one goes up, the other goes up. If one goes down, the other goes down. So far we've linked our environmental condition, we've linked that to resistance, and then we've linked the resistance to potential difference. This will affect the potential difference across the fixed resistor, because it will increase. Because if the potential difference across the LDR goes down, the resistor's potential difference will go up, because the total potential difference remains the same, and potential difference is shared between components in series. So we have a series circuit, the total potential difference will always be the same. Next, since the LDR's resistance has decreased, but the fixed resistor's resistance has stayed the same, so what I mean by that is the resistance here has decreased, but the resistance here is the same, so the overall resistance has gone down. So the total resistance decreases. This is useful because this is going to affect the current. So this means the total current increases and the reading on the ammeter goes up. And that is your final mark. So I'll put that up there for you to have a look at and read over again in detail now. Okay, next question. And this is the final one, seeing as there were so many 6 markers. Here we've got a circuit set up to obtain data to plot a current potential difference graph for a diode. Now immediately looking at this, I'm thinking there's an error here, and we'll come to that in a second. So first you need to draw a diode and a variable resistor. Remember, a diode, there's a line going through the component, we've got a triangle and a line. And for a variable resistor, it's the same as a fixed resistor with an arrow going up to show its resistance can be changed. The student made 2 mistakes setting up the circuit. What mistakes did they make? Well, they connected their voltmeter in series, as we can see here. They've connected it in series. It should be in parallel. That's why that is a mistake. So that's the first one. Secondly, the ammeter is connected in parallel, whereas we know ammeters must be connected in series. So those are the 2 mistakes that were made. Now you might have said he should connect the voltmeter in parallel, they should connect the ammeter in series. That will also get you the marks. Right, add up your marks out of 30 and put that at the front of your paper now.